Hi class, this is an informal video going over some of the concepts from chapters 7 and 8. So some of the questions that students have had have revolved around using the percentiles and probability connected to Z. So the first thing I wanted to review is that we have 3 different Z's. One is based on when you have one score with sample data. Another, very similar, is one individual score with population data. And this population data is more typically used with our z-score distribution. And then our third one is chapter 8, where you have a distribution of sample means. This means that I'm not working with individual data. I'm working with a sample, comparing the sample mean to a population mean. So that's chapter 8. So for our unit normal table, which is like a distribution, our normal distribution, so we talked about the z-score of 0 being at the center, and then you had -1 and 1 within one standard deviation, or within those one z-score, you have about 65% of the scores within that area. So that is, you have that 34.13 connected on each side. So then within 2 is that 95% rule, and that's adding the 34 and the 13.59, and then within the 3. So this is very handy to use if the z-scores that you work with for percentiles and probability are within these even numbers. When they're not, we're going to the z-score calculator, which is zscorecalculator.com. For that one, we would be putting in the z-score we were given or the z-score we calculated. Again, the calculation is going to depend on, am I working with the individual score from a sample, an individual score from a population, or a sample mean compared to my population information. So that chapter 8 formula, remember, is the one that you would have to do an additional calculation to get to standard error. Standard error is analogous to standard deviation, but it's working within a sample mean from the population compared to an individual score. So let's go ahead, and I'm just going to grab a couple slides from our chapter 7 and 8 lecture slides, and again, just have us walk through some practice ones. So again, this is from our practice slides, and this, we're not doing any z calculations. Z was given to us. When we're given z, if we are asked about the probability associated, you might see this information with a P in parentheses. So let's go ahead and do B, because number 1 is one we could do within our normal chart. The same thing with C. A and C I could figure out without having to use my z-score calculator. Again, because I know my normal distribution, I could go ahead and shade the area I need and use this for solving for A and for C. So let's go ahead and do B. So B is asking for what is the probability associated with a z-score greater than 0.8. So when I draw and shade, I would want to go ahead and have the shading area above the 0.8. Remember, z-score of 0 is the center. So I'm asking for greater than. So the first thing I want to do is I want to shade, draw and shade. That's going to help me figure out, did I do it right with the z-score calculator? So I'm going to go to my z-score calculator. I am wanting above, and so I'm going to go to the right side. So it's shading above it. and then I want above a z-score of 0.8. Now, this is the area that I want, and this is the area that's associated. If I'm asking about it as probability, I would use percentages. If I'm asking about proportions, I would use the decimal proportions. Okay, let's go ahead and do number D, letter D. So this is asking for a z greater than negative 0.33. So I'm going to have the z on the negative side below 0, and I'm wanting above that area. So I'm still using the right side, but now I need to put in negative 0.33. So again, it's shading that area because I'm going past this 0. This is all 50%. So I know my answer, just thinking, am I doing this right? Besides looking at shading, I'm able to see, yes, it's greater than 50. So again, the probability would be 62.93%. Let's look at another example. So this is giving me a population mean and a population standard deviation. It is asking what is the probability that I would score between 75 and 100. So the first thing I want to do is ask myself, is this my z-score when I have an individual score? Is this my z when I have sample means? So what do you think? Were you given anything about a population mean and a sample size? You were not. So this is looking at our z equals x minus mu, which is our population mean, over the standard deviation. Because you have two individual scores, 75 and 100, you are going to solve for two z's. You're going to first solve for z for x equals 75. Then you're going to solve for z for x equals 100. Then you are going to go ahead and go back to the z-score calculator, and this is the one that you'd want to use. And you're going to put your z equals 75 here, and you're going to put your z you got for x equals 100 here. So again, we need to solve for those z's, and then you would get your answer. Again, you can always check your answer in the slides. Let's try another problem. So we're given information. A normal population has a mean of 80 and a standard deviation of 12. Find the z-score for the following sample mean. M equals 81 and a sample size equals 36. The first thing I have to do is identify what z am I using. What information am I given? I'm given nothing about an individual. I'm giving a mean for the sample, population mean, standard deviation for the population, and a sample size. That is your Chapter 8Z. I then went ahead and added an additional part to this so we could connect back to our z-score calculator. So this is the formula that we're going to be using. So you first need to solve for your standard error. So you're going to take your standard deviation over the square root of your sample size. So you would take 12 divided by the square root of 36. So then that would be 12 divided by 6, which equals 2. That's going to be the bottom of our z. The top of our z is going to be the sample mean, m, minus the population mean. So it'd be 81 minus 80. So 81 minus 80 is 1. That's the top of the z. Divided by 2 is 0.5. So our z equals 0.5. So then we need to know what is the probability that we'd have a score from our sample means greater than 81. So then I would go to my z-score calculator. I would identify I'm asking for greater than, and I'd put in my z-score of 0.5. So that is that 30.85%. If I had asked what the probability that it was less than, again, I pick the left and I do the 0.5, and that would be the 69.15%. I hope this video was helpful in drawing connections with the material we've discussed so far.